Welcome guys to the latest edition of video lessons. This is going to cover lesson 7.5. It's called Video Volume of Composite Figures. So if you want to follow along in your math book, we'll be on lesson 7.5. We're going to start with our math joke of the day. What do mathematicians eat on Halloween? Any guesses? Anyone? Come on, give it a try. The solution is pumpkin pie. Ha 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 ha. So today we're going to spend some time to finding volume of composite solids. The word composite means a shape that's made up of more than one three-dimensional figure. So if you look at this shape, it's made up of two shapes. It's made up of this rectangular prism on the bottom, and here's the rectangular prism, all down here. And we also have the pyramid that's sitting on top. So here's our pyramid. Okay? So when we want to find the volume, imagine we can take the two shapes and cut them apart, and we find the volume of each of the two pieces separately, and to find the total volume, we would then add them up all together. So this is what the two shapes would look like separately. We have the square prism and the square pyramid. So what we're going to do is find the volume of the square prism. Remember, the formula is area of the base times the height. So we'll do 15 times 15 times 10. And if you have your calculators, go ahead and shout that answer out. And hopefully you came up with 2,250. And for the square pyramid, if you notice, area of the base is the same, 15 times 15, but this height is different than this height. So 15 times 15, then times 8, and here we are going to divide by 3 to get a total of 600. Okay, so to find the volume of this entire composite shape, we take 2,250, add 600, and we get a grand total of 2,850 inches cubed. Any questions, please ask. All right, here we have a composite solid, and what we want to do, I don't know if you can see it from where you are, but this shape, it's kind of like a donut or a washer for any of you who are hands-on. But this is the entire shape. This center piece here is cut out. So what we want to do is find the volume of the shape with this missing piece in the center that's missing. So if you notice, there's a bit more numbers on this diagram because we need to be able to find the volume of each of the separate pieces. So this first figure here is the entire container. Imagine that the center was not cut out. And then this is the centerpiece. We're just imagining for a second the centerpiece was there, and we're going to find its volume. So then we're going to take the volume from this entire thing and subtract this volume that's now missing in the original diagram. So do you see this number, this red line here? This red line in the original diagram represents the radius. The 5 tells us the radius from center to edge of the inner circle. The 9 tells us the radius from the center to the outer edge of the circle. And the 3 here tells us the height of the cylinder from top base to bottom base. And both have a height of 3. So remember, to find volume, we take area of the base times the height. So for this shape, area of the base would be it would be area pi times radius squared. So we're going to take pi times 9 squared times 3. So once we do that, we take 9 squared times 3 times pi, and this total solution will be 763.02. And that's the volume for this figure here. The volume on the right, we're going to take the same equation, volume equals area of the base times the height, and we take 5 squared times 3 times pi, and we get an answer of 75 pi, or 235.5. And that is the volume of this piece of the cylinder. So now we want to know the volume of the piece that's remaining. Well, if this is the entire volume, and this is the piece that was cut out, well, when we cut something out, we subtract. So we're going to take 763.02 and 235.5 and get a solution of 527.5. And again, that's an estimate. Any questions? Please ask. So in this next example, we're going to find the volume of this composite solid. If you notice, it's made up of two shapes. It's made up of a cylinder, and it's made up of a cone. And if you take a really close look, the radius is 3, the height is 4 for the cylinder. For the cone, the radius is 3, and the height is 4. So if you remember the rule about the relationship between a cylinder and a cone when area of the base and the height are the same, we can just find the area of the cylinder, and whatever that answer is, we know the cone is a third of that volume. If you forgot, we can just go through all the steps and find the volume of the cylinder and the cone. So let's start with the cylinder. Volume equals area of the base times the height. So we're going to take 3.14 times 3 squared times the height of 4. Again, we're looking at the cylinder at the bottom here. Then we put this in our calculator. 314 times 9 is 2826. That's the area of the base times the height of 4. And we get a solution of 113.04. To find the cone, since area of the base and the height are exactly the same as the cylinder, we can take 113.04 and just divide by 3. And you should get an answer of 37.68. Let's assume you forgot that rule. We would have to go through all the work. Area of the base times the height, divide by 3. So we would take 3.14 times 3 squared to get 28.26. Times that by the height of 4 to get the 113.04. Divide by 3, and that gives us 37.68. But remember, these two figures are being added together. So we want to find the total volume by adding the cylinder's volume and the cone's volume to give us a grand total of 150.72, or to the nearest tenth, 150.7 centimeters cubed. Any questions, please ask. Okay, for this last example here today, we're going to look at example number 2. So again, from your perspective, I don't know if you'll be able to see this, but we drilled a cylinder out of this rectangular pyramid. So we want to find the volume of this shape with the cylinder that is being removed from the cube. So let's start over here on the right. This is going to be a 3-step process. The first step is to find the volume of the whole cube, assuming the center was never removed. Then we're going to find the volume of the cylinder. The third step is to subtract the total volume minus the cylinder's volume, and that will tell us how much of the volume is remaining. Okay, so step one, we're going to use area of the base times the height. So area of the base is 10 by 14, and the height is 12. So you're going to do 10 times 4. Oh, I messed up in here. Let me redo this math for you. 10 times 14 is 140. Times 12, we should get 1,680. So this solution written here is wrong. We're going to use 1,680. Okay? Let me just cross this out here. Okay, and the volume of the cylinder is area of the base times the height. So we do 3.14 times the radius squared. The radius is in here of 2 times the height of 12, and we get a total answer of 150.72. So to find the total, this total will be wrong in here as well. We will take 1,680 and we're going to subtract 150.72, and we get a solution. Let me just put this here for you. We get a solution of 1,529.3 rounded to the nearest tenth. 1,529.3. What's our unit here? Inches cubed. So this would be our final volume for the shape. Okay, any questions, please ask.